Right, this is tutorial number 2. A lot of people have been asking about this. One of the more tricky subjects in chemistry, and that is the subject of electrolysis. So we're going to look at electrolysis, a basic introduction into what electrolysis actually is. So the first thing, I suppose, is the definition of electrolysis. And what we're doing is we are breaking down a compound using electricity. So the definition of electrolysis is breaking down a compound using electricity. What do we mean by electricity? Well, simply we mean a flow of particles called electrons. And an electron is a tiny particle. It's a tiny particle with a negative charge, and we show the particle like this, E minus. Okay, so we've understood now what electrolysis is. It's breaking down a substance using electricity. We've understood what electricity actually means. Now, let's have a look at a particular substance, and the substance we're going to look at is something relatively straightforward. Let's have a look at potassium bromide. Now, the first thing we have to look at in potassium bromide is it's made of two substances. It's made of potassium, it's made of bromide. It's a chemical compound made of two elements which are bonded together. Now, how are they bonded together? Well, because potassium is a metal, and because bromine is a non-metal, we know the bonding must be ionic. Ionic bonding occurs when you get a metal bonded to a non-metal. So the very fact that the substance is ionic means that it is made of ions, and that's going to be absolutely key. Now remember, an ion is a substance with a charge, either positive or negative. It's not really important how it got that charge, but it would have something to do with electrons. Right, let's have a look at the substance potassium bromide, and we'll look at it now as its formula. Potassium bromide is KBr, and it's a solid. Now the reason it's a solid is because we've just decided that it's ionic, we've just decided that it's made of ions, and if we know this, we know that the structure is a giant ionic lattice. This is a regular arrangement of interlocking ions. Now, in order to break this down, we have to do something first. This is something which is nothing to do with the process of electrolysis, but it's something we've got to do is to get these ions moving. So think about these ions, think about the fact it's a solid. One thing you know about these ions is they're going to be locked in place. A solid means that you've got a regular structure and none of these particles are free to move. Right, if we start therefore with the substance potassium bromide as a solid, the first thing we need to do is to turn potassium bromide, KBr, into a liquid. The way in which we do that is we apply heat. We apply enough heat in order to melt the potassium bromide into potassium bromide liquid. And the key thing that this enables to do is now the ions, the potassium ions and the bromide ions, can move. If ions are able to move, then we're going to have our first stage and be able to separate the potassium bromide. Right, now what we can imagine is if we've melted our substance, we can imagine that in this basin is our potassium bromide. It's a liquid like this, and what we're going to have is we're going to have lots and lots of potassium ions, K+, and we're going to have lots and lots of bromide ions, Br-. Please remember how we work out its K+ and Br-. K is in group 1, 1+, bromine is in group 7, 1-. Now at the moment these are just floating around. The substance hasn't been separated at all, because as soon as we let the substance solidify, it's just going to go back to being KBr again. What we have to do is we have to get rid of these charges. We've got a positive charge over here. We've got, tell you what, I'll do that again. We've got a negative charge over here, and these are the charges that we wish to get rid of. The key thing to remember is, how did potassium become K+? How did it happen? Well, the way in which it happened is it lost an electron. So what we need to do is we need to give it that electron back. How did Br minus form? How did it get that negative charge? This negative charge here. Well, it gained that negative charge by gaining an electron. So what we need to do is rip that electron away. We need to add an electron back here. We need to remove an electron on the left-hand side. And the way in which we do this is we're going to put two things called electrodes into here. So let's place one electrode there and another electrode here. These electrodes are going to be formed from graphite, and these electrodes are going to complete our circuit like this. They're going to be joined to a, this is harder than it looks, it's going to be joined to a cell up here. Now, one of the things you know about a cell is it's going to generate electricity. So this thing here this cell here is going to generate electricity. Electricity is a flow of electrons, and what happens is these little electrons are produced from this big fat bit here, and these electrons, which all have negative charge, move down this electrode and into our potassium bromide. What's going to happen is the K+, which is of course attracted to negative charge, is going to pick up one of these electrons. The charge is going to be cancelled out, and we're going to form K. These electrons are therefore removed as the K plus picks them up. So the electrons here are going to be removed as they're picked up by the potassium. If we look at what's going to happen to the Br minus has an extra electron. That's where it got this negative charge from here. And so what the bromine's going to do is it's going to lose an electron, minus E minus. And if you take an electron away from something which is negative, you lose that charge and you form bromine here. What happens is the electrons are dumped onto this graphite electrode stick and they move back into the top of the cell. What this does is effectively down the right hand side, electrons are produced and are picked up by the potassium, and as we can see that over here. On the left hand side, the electrons are dropped off by the bromine, and we can see that here. Now, just in terms of neatness, as you know, the formula for bromine is actually Br2, and therefore, just for the sake of balance, we need two bromide ions, and we need two electrons here. This now is balanced, and I suppose if you wanted to balance up two electrons on the left-hand side, you'd end up with the potassium being doubled, but of course they're both balanced equations. To produce one bromine molecule simply requires two electrons, and that is the very basis of electrolysis.